Today we are going to learn what is transverse waves or shear waves. Okay, this type of ultrasonic wave is called a transverse or shear wave because the direction of particle displacement, that is vibration, is at right angles or transverse to the direction of the propagation. You understand, right? Particle movement perpendicular to propagation of wave. So it is called as transverse wave, right? It is called as transverse wave. Now you see, this wave is moving in this direction, but here the particles are moving perpendicularly. It is going down. Sorry, it is going down, and this particle is going up, right? This particle is going down. You see, particle movement is in this direction, but wave direction, this is wave direction, right? This is particle direction. If you see both of the, what is the angle? 90-degree. That's why it is called as transverse wave or shear wave. Okay, for such a wave to travel through a material, it is necessary that each particle of the material is strongly bound to its neighbors, so that as one particle moves, it pulls its neighbor with it, thus causing the ultrasound energy to propagate through the material with a velocity which is about 50% that of longitudinal velocity. You understand, right? So they are telling that, so here what is happening, the particles are moving up and down, but wave is propagating the forward direction. You see, the particles are moving up and down, so there is some bonds between this particle and this particle, right? There will be some bonds between elastic bonds, this particle and this particle. Now if suppose this particle got some energy, okay, now if there is no strong bond, then it cannot pull, this cannot pull this particle, okay. Then there is no transmission of wave, that the wave will not get transmitted. There is no, because it is not able to pull, this particle, because there is no strong bond. If there is a strong bond, then suppose there are two persons are there, okay. Two persons are there, one is holding the other's hand, okay. There is some strong bond is there. Now he can pull this guy, this person. But if there is no bond, if there is no, like, if he is not, there is no strong bond, he cannot pull this person. Then this energy will not get transferred, okay. Okay, if, okay, to a material with velocity which is equal to, so which is about 50% of that of the longitudinal velocity, we know that. So here it says that velocity of shear is equal to 0.5 times the velocity of longitudinal wave. Okay, for all practical purposes, transverse waves can only propagate in solids. So only in solids, transverse waves. This is because the distance between, why only solids? The distance between the molecules or atoms, comma, the mean free path is so great in the liquids and gases that the attraction between them is not sufficient to allow one of them to move the other more than a fraction of its own movement, and so the waves are rapidly attenuated. What they are telling is that in the solids, see, in the solids there will be tight bonds, okay. There will be tight bonds. When this particle is getting energy, it gets transferred to this particle because this bond is there, okay. This bond is there, this is the bond, and here also this is the bond. So but in the liquids, na, the mean free path, what you call mean free path, is very high, and the distance between the molecules is very high, that this particle cannot transmit this energy to this particle, uh, because this cannot pull this particle, okay. Okay. Okay, the transmission of this wave type through a material is most easily illustrated by the motion of a rope. Okay, so rope as it is shaken, each particle of the rope moves only up and down, and the wave moves along the rope from the excitation point. You see, here there is a wall. Okay, and you know this the, in the gym people will do it, right? Thread. Okay, this is the rope. Okay, if you are moving the rope, the rope will move like this, right? Will move like this. Okay, here this particle is staying in the same position, but it's moving up and down, but the wave is going forward, right? Wave is going forward, but this particle is moving up. Once it is moving up, and next moment it's coming down, then moving up and moving coming down. So particle movement is in the perpendicular direction to the propagation of wave, and the particle is not moving. This here the particle is moving up and down. It's not moving forward. You understand? You understand, right? Why only solids? Because here you see this is a thread. Okay. Now you see this is pull. This is at this point this thread. Okay. This is pulling this particle, right? If there is no strong bond, it cannot pull this, so this thing will not happen in the liquids and gases, so it's not possible to for the transverse shear waves to go in this.